Mr. Jaspal Singh, anyway, he will be telling about his background. But personally, I know him last more than 25 years. When I did my diploma in industrial safety, Mr. Yashpal Singh was one of the faculties, and I am personally trained in the safety courses. That is from 2001. I know him personally. Then he started his own organization, that HSC, RMS, and last I think he'll be telling all these things. But this is how I know personally him. That I give the background. He's one of the 35 years experience in this field, one of the most senior person according to me in the field of safety. So I requested Mr. Singh, sir, why we should not take one session for our CEP, and he kindly accepted our request. And that's finally today we are here and we can see him also in the screen. Thanks on behalf of CEP. Thanks to Mr. Jaspal for taking this session. I am very sure this session will be very helpful for all the safety professionals. So what we learned it, implement it. The objective of the CEP is that sharing the knowledge without any financial burden. So that is the objective. Last 10 years we are doing, and we are doing without any deviation from our objectives. And you know that you have joined Mr. Jaspal Singh, everybody, for the good cause of the society, to share the rich knowledge of safety. We started and we are doing, in future also will be doing. And thanks to all of you, those who have participated. Now over to Mr. Jaspal Singh.
Thank you very much, sir. First of all, I think I should congratulate you for completing 10th year, and really grateful for this wonderful cause. And regarding student, actually, we had a difference of 1 year only. Before that, I was also a student when I started doing the lecture. It's what I understand or learn from the seniors, I just transmitted to next batch. So there was not a much difference. There was a difference of 1 year only. Okay. Apart from them, thank you very much for allowing me to share my experience and knowledge with the team. So I'm starting with the presentation directly. I hope my audio is clear to all of you.
Yeah, it is clear.
Okay. Yeah. So today I'm going to discuss, we can say, and share my experience for the safeguard and independent protection layer. So that is the basic in all the risk assessment. So the agenda for today's this webinar is emergency preparedness, about our company definitions, important definitions in today's presentation. Then about the safeguard, type of safeguard, about the independent protection layer, type of IPL, difference between IPL and safeguard, some example scenarios and exercise. So these are the main agendas of today's webinar. So starting with the emergency preparedness, I request all of you, those who are in the conference room, please quickly review about the your company or your location, siren type, evacuation route and assembly point. So basically, this is very important because we know all the fatalities happen in the public life is mainly because of improper evacuation or evacuation route or no guidelines. So
excuse me, sir. You have to present the PPT, sir. Please.
Sorry. I have to share it. Okay.
Yeah, now it is visible.
Visible. Okay, thank you. So thank you once again for the reminder. I quickly start with the basically emergency preparedness. So I humbly request all of you, those who are in the conference room or sitting together, please check your siren type of your location, company, evacuation route and assembly point. So this is basically important because we know most of the fatalities are because of improper evacuation. So we should always take care of this whenever we are together in the assembly room or somewhere else for the discussion and presentation. So now starting with our company is HSC Risk Management Services Private Limited, founded in 2006, and almost we have completed the 19 years and we are in 20th year. We work in the 10 countries, we on the 70 different locations. Basically, this is a journey we started in 2006 and now into 2025. So we started with the 2-3 studies like HAZOP, audit training. Now we are doing almost 48 type of different studies. We added few softwares also during our journey. So if I would like to summarize, so summary is like the total HSC studies conducted until January 2025 is 1,000, which project wise, this is almost 750 plus projects we did for different companies. Already 48 types of studies we already completed. We are doing right now also. The clients total in the 10 countries, we are almost 140 plus clients. That is, if category wise, 26 type of different industries like pharmaceutical, petrochemical, oil and gas. So this is the summary. The studies which we are doing right now, our services includes the different HSE studies like HAZOP, SEAL, all the PSM studies. Now regulatory, legal and legal compliance, or documentation like Schedule 7, Schedule 8, auditing, different type of audit we do like PSM, safety, electrical, energy audit. And of course, we have started recently the PSM Academy. So that includes the different certificate courses, 1 week, 1 month, 1 year, 6 months. So we are now in the phase of obtaining the accreditation for all these courses. Hopefully we will start by July 2026, all the courses, but 1 week courses will start from the October or November. That will also be certified courses. Summarizing the different studies, so total HAZOP we did until now 620 plus, hazardous area classification 55 plus, QRA 25 plus, project HSC review, that is phaser 100 plus, safety audit almost 130 plus, hazard, that is hazard identification 45 plus, safety training 80 plus, that is for the as a professional, but by honorary we have done almost more than 100 other. So 80 plus 100 we can say total safety trainings. These are the few of our credentials, like we are registered with the MSME, we are CRISIL verified, trademark registered, ROC registered company, and ISO certified company. Okay, this is what about our company. Now, starting with the definition, I will request you to write down if you have any queries. So in the end, we will keep the question answers, maybe 15 minutes to 20 minutes. So please write down your all the queries. So I start with the definition, which will be useful, or maybe we will use this terminology during the today's presentation. So starting with the HAZOP, basically it's a hazard and operative study. So you can, I think you may be well aware about the HAZOP. It's a structured, systematic review of the process to identify deviation from design intent, their causes, consequence, and safeguard. So in general, we can say HAZOP is to identify the risk in the process. So in general, if you can, you have the your any chemical, petrochemical units or pesticide farmers. So we can divide the total activity of the site in 3 categories. One is your routine activity, which other than process. Second is your process, and third is your non-routine activity. So normally we do the risk assessment minimum in 3 categories for all the sites. That is for routine activity. Normally we do hierarchy. For process, we do the HAZOP for the risk assessment. And for non-routine, normally we do the GSA, and the objective of GSA to identify the hazard in non-routine. So our maintenance activity comes in the non-routine activity. From that, normally we design the work permit system also. So that is one of the objectives of GSA also. Second layer of protection analysis, that is a LOPA. So LOPA is a semi-quantitative method to assess whether existing safeguards reduce the risk to tolerable level. So basically difference in HAZOP and LOPA. So HAZOP normally it's a purely we can say qualitative. When HAZOP was actually designed and published the first guideline, that was in 2006 by the CCPS. At that time, normally we were doing only the risk ranking after the safeguard. So basically that was, we were calling it as a qualitative method for the risk assessment. But later on now, people started doing the risk ranking after the safeguard, after the recommendations also, and after the consequence. That is the potential risk, after the consequence, then after the safeguard, that is the initial risk, and after recommendation, final or residual risk. So assessment, we know that assessment means comparison of the 2 different benchmarks or different values. So now we call HAZOP also as a semi-quantitative method, because we are comparing the risk in 3 level or 2 level, like after consequence, that is the potential risk, after safeguard, that is a initial, and after recommendation, residual. So now we can call HAZOP as a semi-quantitative, but initially when this was started, so only after the safeguard, so that was a qualitative method. So layer of protection analysis also is a quantitative, it's a semi-quantitative method, but in the LOPA and HAZOP, there is a basic difference that in HAZOP, we do risk ranking only, but in the LOPA, we also use the failure frequency for different cause, consequences, or safeguards. We use the probability. So there is a slight extension of the HAZOP we use the failure frequencies also. So that is a basic difference. Other difference between HAZOP and LOPA is in the HAZOP. Normally we can say check the adequacy of complete process. In the LOPA, we check the adequacy of the deviation. So deviation adequate with respect to the safeguard. There are some other basic difference also that we will cover later on. That is a total objective of our today's webinar. That's in HAZOP we use the safeguard terminology, where in LOPA we use the independent protection layer. Now comes to deviation. Deviation normally is a departure from the design intent the process variable, that is high pressure, low flow, high temperature. So purely all the risk assessment is based on the deviations. Normally we when design the process or design the routine activity, so everything we design an envelope for that particular process. When we do the risk assessment, normally we try to see outside the design envelope. So that is the basic difference between deviation and design envelope. So in the design deviation, departure from the design intent or design envelope in a process variables. For the HAZOP, that is the for HAZOP. But if we talk about the routine activity other than process, the same thing, departure from the design intent in your activity. Similarly for the non-routine activity also. So that is the basic for the deviation. Now consequence, impact of the hazardous deviation. Like if there is a fire, so what will be the impact? If there is a toxic release, so what is the impact on the human being, impact on the environment? So there is a delay in the operation, so what will the impact on the your total productivity? If there is a damage to asset, so what will the impact? Sometimes there is a loss of production or there is a shutdown because of that, this consequence. So what will be the impact on the reputation? So basically consequence normally we do in 4 categories. That is impact on the human being, impact on the environment, asset, and your reputation. Now industries also categorize this consequence into legal aspect also, sometime some other categories on their own requirements. So consequence, basically our main objective is people, asset, environment, and reputation. We can subdivide also in the other parts also. Now mitigation. So when we say consequence, so reducing the effect of consequence, that is a mitigation. So measures should taken to reduce the severity of the consequence if hazardous event occurs. So mitigation and prevention, there are 2 words normally. This is related to safeguards and IPL also. Just we are understanding the basic terminology here. What is mitigation and what is prevention? So mitigation is measure taken to reduce the severity of the consequence if a hazardous event occurs. And prevention is measure taken to reduce the likelihood of the hazardous event occur. So just directly we can relate, like prevention is mainly related to the cause of in the HAZOP or LOPA, and mitigation is related to consequence. And to differentiate between your prevention and mitigation or cause or consequence, we can take the one example. Suppose we say there is a reactor in which there is a reaction is taking place. In case of increase in the temperature, there is a possibility of runaway reaction which increase the pressure, resulting in damage of the reactor, release of the hazardous material, maybe hazardous, so release of the material. And if it's a flammable material which may convert into fire on the in the presence of the ignition. This is a total complete one example. So here we can just understand what can be the preventive things and what can be the mitigative. So just boundary is that whatever is in your control before the release or before the consequence, that can be the part of the prevention system. Prevention safeguards, prevention layer of protections. So measure taken to reduce the likelihood. So probability of happening that event, that is a prevention. In general, we can say. So that is why when you see that in the case of safeguards also, we change the probability always. Only change the severity is possible in case of there is a design change. Otherwise, our total concentration on the reducing the probability of happening of that event. So that is the basic thing. And in the case of mitigation, normally it's when we reduce the severity, like there is a fire, so we control the fire, we confine the fire. So that is the objective of reducing the severity, means mitigation. In general, we don't reduce the severity here, but we just confine that consequence, or we just reduce the impact of that condition. Like in case of fire, we use the firefighting system. So that will reduce the impact of the fire. That will not reduce the potential severity, but ultimate effect on the people or effect of the assets. So that is the basic difference between prevention and mitigation. In case of prevention here, in our example, we say if there is a runaway reaction, there is an increase in the temperature. If we control the temperature by giving the controls, shut-off systems, or in case of runaway reaction, we have another controls like more pressure controls or raw materials, stopping the raw materials. So all these are the preventive up to before release of raw material. If there is a high pressure also, then if we have the PSC, so that is also preventive in this particular case. So case to case safeguards can change. It can be preventive or mitigative. We will discuss it later on. Prevention and mitigation is very important in the risk assessment. Now, mechanical safeguard. So physical device or system to prevent accidents by protecting operators and controlling machinery. So here we are discussing the safeguards only. So later on we will just define safeguard and independent protection layer. The same definition is applicable for protection layers also. So administrative safeguards, so procedural measures like SOPs, training to prevent or mitigate the hazard. So that is administrative safeguard. Hardware safeguards, so equipment system to prevent the mitigated hazards events like PSC can be the hardware also, rupture disk, shutdown system. So these are all the hardware safeguards. In mechanical safeguards, specifically if we define, so in that case, like your orifice also can be the mechanical safeguard. So these are the few examples of the different safeguards. Now definition, safety integrated system. So there are two things, SIF and SIS. So automated system that takes action to prevent the accidents and maintain the safe operation. So SIS, we can say, give the example of complete shutdown system. In case of SIF, safety instrumented function. So if we take one loop, like we have a temperature controller, like we have the control valve, in that we have the temperature transmitter. The transmitter will sense, detect, check the temperature, detect the temperature, then transmit the value through loop to the controller, and controller will take action. So this is one loop. So one loop is called as a SIF, and multiple SIF is a SIS. So in SIS there will be multiple loops, maybe 2, maybe 3, maybe 5, maybe 10. So all shutdown systems which having more than one safety instrumented function or control loop is called as a SIS, safety integrated system. Audible. So audible will be helpful and is related to the loop layer of protection. So a safeguard can be tested, inspected, and verified. So audible means any safeguard which can be tested, inspected, verified, recordable. So anything which is, say, suppose for the example, we have the temperature transmitter. So temperature transmitter's objective or life is for the 10 years. So that should be regularly inspected and tested. That is important. If we don't inspect and we don't test it, so that may not give its actual performance which is desired from the temperature transmitter. So first thing, for maintaining the temperature transmitter performing its up to its objective or performing to the objective, first thing we should inspect it, test it. So that is the first thing, that should be testing and inspection should have the records. That is audible. Then our monitoring of parameter temperature in particular reactor, that should also be recorded. So complete thing that is audible or recordable. So basically audible, recordable is a part of the audible. So because if we have any record, then we can audit it. So audible and recordable is a one terminology. Normally we use for layer of protection basically. Then independence. Basically this is also related to the protection layer. The safeguard must function without being influenced by the initiating event or other safeguards. Say for example, to understand this, let us take one example. There is one reaction is going on in the reactor or distillation column. There is a separation process going on. So suppose we have one temperature transmitter when we have one pressure transmitter, and we say there is one alarm for the temperature transmitter and one alarm for the pressure transmitter. Now response by alarm is by same DCS operator, maybe same, maybe different. In case of same DCS operator is responding to both the alarm, so these alarms are not independent because dependency on the operator. If both alarms are responded by different operators, so there are two operators for responding to alarms, so it's independent. So independence is based on the initiating event or other safeguards. So we have to check initiating event also, we have to check the safeguard also. I would say if it is independent, then we can consider as a protection layer, as an independent protection layer. So there is a basic difference between safeguard and a protection layer, so that we will see later on. But independence means independent from initiating event or all the controls. In general, we can say. Initiating event, initial condition that triggers a chain of event leading to the hazard. So we take, again, we refer our first example of there is a reaction going on and increase in the temperature. So increase in the temperature may be because of human error, inadvertent opening of your steam supply valve or hot water supply valve, or maybe because of if there is a XV in the steam supply line, so stuck open of XV. So that is the initiating event which leads to increase in the temperature. So here our human error or stuck open of the XV is the initiating event. Now, risk reduction factor. Basically, risk reduction factor or RRF. And again, next definition, probability of failure on demand, PFD. These both are related to the protection layer, IPL only, not related in the safeguard. So risk reduction factor is a measure of how much a safeguard reduce the risk or control reduce the risk. So in case of risk reduction or probability of failure of demand, there are two units. So RRF is mainly in the digits, so maybe 10, 100, 1000. So basically values for RRF, we refer from the CCPS. There is a one table which we will refer later on. So there are standard values that we have to refer and use for the risk or HAZOP or LOPA. Probability of failure on demand, it's a likelihood that a safeguard system will fail when required. So it's a once in a 10 year, once in a 100 years. So 1 into 10 raised to minus 1, 1 into 10 raised to minus 2. Like that, we just write down the values. Redundancy involves duplicating components of system to ensure safety and reliability. So if we are using, so there are different requirements in the redundancy may be required for safeguarding, may be required for the inspection testing. Say one example, if there is a LPG or anhydrous ammonia storage tank. So normally we use 2 PSV, we install 2 PSV in that particular time. So their redundancy is for the testing because anhydrous ammonia or LPG normally pressurized compressed gas, we normally don't empty out for the inspection testing, not possible. So in that case, suppose we have to inspection and test the PSV. So we have to remove the PSV from the tank and we have to test, do the inspection and testing. So during this inspection testing, only one valve is available. So for the control, we will consider one safeguard or one protection layer. But redundancy is required for the inspection testing. Second redundancy may be like in the distribution control system. Just to include the redundancy of the controls or safeguard, we provide in the DCS redundancy in the modules, redundancy in the system to make it redundant for all the safeguards and controls. So these are different requirements for the redundancies.